Welcome to day one of our challenge, and today we'll be focusing on linear regression analysis. So without wasting much time, let's go over to the Chi-Squares platform and let's see how we can set up a linear regression model. If you're new to the platform, you can go to chi-squares.com to sign up and create an account. If you already have an account, just log in. So I've already logged into my account, and so let's get ahead. I will start a new project, and I'll call this linear regression. And next, I would upload the data set we'll be using for this analysis. I'll click on upload, and the data set I want to use is right here. So the task for today is for us to use data from a large national US survey to set up a linear regression that assesses the relationship between quitting smoking and weight loss. And so this was a longitudinal survey where a bunch of smokers were followed up over many years. And then the data set collected information on their weight at baseline and then at follow-up. And so what we're primarily trying to assess here is quitting smoking associated with a change in weight? Weight is obviously a continuous variable, and so it's fitting for us to use linear regression in this case. To fit a linear regression model, we would come to estimate and we'll go to regression analysis. And then we can then select the type of regression we wish to run. In this case, a linear regression. We select our outcome by selecting the drop-down menu and searching for the outcome. In this case, the weight variable changed between 1982 and 1971, which was the baseline. We select that variable. We can only have one outcome in a linear regression model. Next, we select our predictors. We'll start with the main exposure for this research question. We're using a causal framework where we have one primary exposure, one primary outcome, and a set of confounders. Confounders are variables that are associated with both the exposure and the outcome, but do not lie on the causal pathway. So here we're going to use quit smoking as our primary exposure, but then we also have our other potential confounders, which we're adding to this analysis. So those included whether they were physically active, whether they were married, their exercise levels, their education level, their income category, their race, their sex. And then we also had other variables like their smoking intensity, how much they smoked. I believe that was SMK smoke intensity right there. And then we also have their age. Those were some of the variables that we were interested as potential confounders of the relationship between quitting smoking and weight change. So we have our variables here. Next thing is for us to select the reference categories for our variables. When you select variables here, you have the options to choose the reference categories as the case might be. Here we have the platform automatically selects the group with the lowest reference or the largest sample size as the reference category. But we can change that if we want. So here, for the sake of this demonstration, I'm going to keep those reference categories as they are. Active category, I will select 2. The documentation for today provides the meanings of each of those codes. So it will be a great practice for you to go ahead and give them very distinct labels that you can understand before proceeding with the analysis. Marital category, again, I'm going to select 1 here. But again, you should absolutely record those variables so that you are very clear of what 1 or 2 or 3 means, because without that, then you have no context for what the results mean. And so we're going to do that for all of the variables in here. For those that are continuous, the platform automatically treats them as per unit increase. Once we've done that, we can assess for confounding by coming here to model optimization and clicking on confounding variables. This allows the platform to empirically check whether the variables you have selected are actual confounders. You can change the threshold here for significance. Here, the default is 0.2, P 0.2, which is a 20% alpha level. In general, we use a larger threshold for assessing confounding than in the main analysis. So in this case here, the platform says these are the variables that were independently associated with the exposure and with the outcome. You can click this button here to look at the results from bivariate analysis. And so that way you can see how the platform came to that conclusion. Now, once we are done with that, we can then estimate our results or run the analysis here by clicking this button. So here the platform takes the results that we have, the inputs that we've provided, and then it then estimates the model, and then it will show us the results accordingly here. So here, this is what we have as far as the results. You have the predictor variables here, you have the comparisons in question, and then you have the coefficients provided here. This coefficient in a linear regression means the differences in means between the groups being compared versus the reference groups. So for example, compared to those who did not quit smoking, we see that those who quit had an average of 3.08 kilograms, I assume, if this was measured in kilograms, right? So this tells you actual differences in means between the groups being compared. And the p-value here tells you where the results were statistically significant. Now, if you wish to look at the figures, the platform also provides plots for you. You can also look at the write-up of the results here. Now, one very important thing we do is to check whether or not the assumptions for linear regression were met in the first place. And to do that, you can come to the metadata. And under the metadata, you have different indicators. So you don't have to guess whether the four major requirements for linear regression were met. The platform explicitly will tell you whether or not they were met. And part of the homework is for you to, one, explore, think about what we need to do when those assumptions are not met. So I'm going to release another video in the next few hours that shows what we can explicitly do in cases where each of those assumptions are not met. For example, here we know that linearity holds, but we see that the assumption of homoscedasticity was not met, right? We also see that there is no autocorrelation, which means that's a good thing. The observations are not assumed to be clustered or they're independent. But here we see that residuals are not normal. And so this way, the platform explicitly tells you what's wrong so that you can correct it. So again, the task for today is for you to, one, recode the variables so that you're not just looking at numbers 0 and 1 and wondering what a sex or gender of 0 means. So recode the variables to align with what's in the code book. And then number two, fit your regression model and think through what we can do when these assumptions are not met. Thank you very much.